Outliers can cause problems in our data set. Therefore, when we have outliers in our data, we need to do something about that. But the choices that we make about how to fix outliers will depend upon the causes of those outliers. It is quite possible for us to have outliers in our data set that represent legitimate extreme scores. Usually this happens on a single variable. We have someone in our data set who is unusually tall, or heavy, or smart, or rich, or old, or some item that is particularly expensive, such as a house in a neighborhood that has a low median income, but a large, expensive house on the corner. What then should we do about these legitimate extreme scores? Scores that are real, that are truly part of the population, but are extreme and may be causing problems in our data set. First, we should look at the overall data set. We know that these legitimate extreme scores reflect random selection. For instance, in an example where we are measuring ages, we find someone who is over 80 years old. However, that person is truly part of our population. Yet, their large score for the age is going to be balanced out by the large number of younger people, and essentially that data point is not going to cause any problem for analysis. It's also quite possible that the variable in which we find the outlier is not actually part of our analysis. I would report the average age as part of the demographics of the sample, but I'm not analyzing age as part of my research. Another cause of outliers is a data entry error, where the data have simply been entered incorrectly. In this example about food processors, we see that one food processor weighs 14.5 pounds, another 6.5 pounds, but the one in the middle weighs 167.5 pounds. At this point, you don't know what the true score is, but you can guess that it's not 167 pounds. Most likely, based upon scores around it, it should have been either a 16 or a 17. We could use that information for fixing an outlier. So for instance, if you have an item that is scored on a scale of 1 to 6, and yet in your data set the score is 66, we can be pretty confident that that value is supposed to have been a 6, and that is easy to fix. Another cause for outliers could be sensor malfunction. Let me explain. Data can be collected in a multitude of ways. One way that data will be collected is using some kind of measurement device that is electronic, and that device may not be working properly. In this example with temperatures, pay attention to the orange box and that white circle. These are temperatures in the winter. These are the raw temperatures, the true outdoor temperatures. Now let's look at the wind chills. We see that the numbers in the orange box have dropped dramatically by several points. The wind chill is making it feel much colder than just the raw temperature. However, within that white circle, the numbers haven't changed. The formula for wind chill is calculated with the temperature in Fahrenheit minus 0.7 times the wind speed. The fact that the numbers in that white circle don't change when numbers around them do change suggests that there could be a failure of a wind speed sensor. That bad data, or more accurately, missing data, is giving us a false reading, making those wind chills appear larger than they truly are, creating outliers. Another time that outliers will occur is where we get a data point from someone who is not actually part of the population. In this example, we have ages collected from 2 college classrooms. In classroom A, we see ages that we would expect for typical college-age students, running from 18 years old to 22. But in classroom B, we have the same typical scores and an outlier at age 48. What went wrong here, and what accounts for that outlier? Now, it could be that the professor in this class helped to fill out a form and that person submitted a survey that, although perfectly legitimate, is not part of our population. We are measuring college students, not college professors. So in that case, we would simply throw out that particular survey. It would not be included in our analysis. There's another time where these types of scores can occur. Perhaps we have a student in an elementary school classroom who is bilingual. This student is new to the United States and hasn't learned English well. As a result, this person's scores are artificially low. If the scores are not part of the population, we shouldn't include them in the analysis. So while this person is certainly part of the classroom, those scores are not representative of the typical scores that we would find. So we would probably remove that data point. Another reason why outliers can occur in your data set is what I call jerks, which is a way of saying people who are not taking the survey seriously. Now, years ago, I had the good fortune of doing some research with junior high school students. And I determined from looking at that data set that junior high schoolers are not always reliable reporters of fact. Some of them were not taking this survey seriously. When that occurs, we get outliers in the data set that do not represent true scores. They may not actually be outliers, they're just not serious participants. Now, here's a quick little idea. If you're doing survey research with junior high students, I found that students who are messing with you want you to know that they're messing with you. And so I included an item at the end of the survey that said, I took this survey seriously and answered the questions honestly. And I found that when I examined the answers of those who said, no, I didn't take this survey seriously, their data was a mess. It was a pretty reliable indicator that they weren't taking the survey seriously, and that is a good idea for inclusion anytime you're dealing with a more resistant population that you are measuring. Here's another time when you can get these kinds of jerky outliers in your data set: bots. If you do online research, it is very likely that some of the people answering your survey are not people at all. The best and most simple way to avoid getting bots answering your online surveys is to not include any kind of incentive. If you are offering a $5 Amazon gift card for completing this survey, your survey is going to be inundated with no-goodniks whose job it is to run internet bots looking for those kinds of surveys. They will fill up your data set with trash, so don't bother. If you're looking for bots answering a survey, you might want to look at the time code within your data set. If a survey should typically take 5 minutes to complete, and yet one participant was completing the survey in 15 seconds or 5 seconds, that's probably, well, that is a bot. So you can safely exclude that from your data set. And no, you don't have to send them a gift card. The choices that we make about fixing outliers depend upon the causes of outliers. So let's see, what are our choices for fixing outliers in a data set? If the outlier is legitimate, you should ask yourself 2 questions. Number 1, is it part of the population, and is it causing a problem? If this outlier is part of the population, if you can, you should leave it in the data set. However, you may Winsorize by bringing that extreme score down to the most reasonable highest score in the data set. It's still the highest score, but it's no longer an outlier. Another excellent option is to report the 95% trimmed mean as well as the arithmetic mean. If the data point is not causing a problem as an outlier, you can safely leave it in the data set, especially if this variable is not one that you're going to be analyzing. That person who was over 80 years old will have that age balanced out by the younger people in the data set. On the other hand, if the outlier is causing a problem, we must choose some other alternative. It's possible, especially if we have a great many outliers that are truly distorting our sample, we may use a non-parametric test instead of a parametric procedure. Or we could run a parametric test both with and without the outlier and then report the results for both. Here's some other options for fixing outliers. If the outlier reflects a data entry error, simply correct it. You may need to approximate. If the score could be a 16 or a 17, you might split the difference and call it 16.5. Another excellent option is to Winsorize your outlier to bring it down in line with the next highest score in your data set. As a last resort, you could throw out the case with the outlier. However, do this only if that case truly does not belong in the data set. For example, if this individual was not taking the survey seriously, was giving you bad data, or was simply not supposed to be in the population that was being sampled. The rule about trying to keep an extreme score in the data set, if possible, applies to univariate outliers. In the case of a multivariate outlier, we really only have one option. To explain univariate versus multivariate outliers in determining when outliers should be deleted, let me draw what I hope will be a funny analogy. We all have friends who are a little idiosyncratic. They're different, they're fun, they're odd in a quirky way. They're crazy in one way. Those people are endearing. And so you should keep that friend as part of your social circle. That person is a univariate outlier because we're all a little crazy in one way or another. On the other hand, if you had a friend who was crazy in a whole lot of ways, you might not want to keep that person as a friend. A multivariate outlier is one that is messed up in all kinds of ways in your data set. And when that is the case, you only have one option. You must delete multivariate outliers. You can keep univariate outliers, but multivariate outliers will always mess with the analysis. They cannot remain in your data set.